Welcome to lecture 53, which is on input data to the GIS. As I told in my previous lecture that data input is very important. What are the different sources from where we are taking the data and what is the quality of the data, so that we can get a good and accurate output. So let us begin with that GIS data. So as we know that now that there are various sources from which we can acquire the data at different resolution with different accuracy. So paper maps would be available at different accuracy, whereas the digital data which you are collecting from the ground will be available to you at a different accuracy. So you have to bring everything together at a common platform, and uh, this hard copy data you have to actually convert into the digital form first of all. So we have lots of hard copy data which could be available in the form of the maps, in the form of the reports, atlases, research papers. So which we want to really use in our analysis part, but they are available in the paper format. So this data has to be first converted into digital forms. There could be several satellite images, there could be some aerial photographs, photographic data. So this is all first converted into digital form and georeferenced together with the other data products in order to use it. So if we look at what are the different sources of the input data to the GIS, we can have computerized data, digital maps, analog maps, manual file data, data which is coming from the land survey, satellites, on internet data. A lot of data nowadays is available on internet. So we can make use of that data also in our database. So but all that data is to be actually first of all processed properly so that it is usable. Now there are two methods of spatial data acquisition. One is the primary method of data acquisition, and second method is the digitization and scanning method. So in this lecture we are learning the second method, that how this digitization and scanning process could be used, how the secondary methods could be used to create digital data from the hard copy data products. If we look at the different methods, what are the different modes through which I can give input to my data, GIS. Now, a very old method, when computers were not available, when scanners, digitizers were not available, is the grid overlay method. It's a manual method completely, where on the map the grid is superimposed, and then under each grid we identify which kind of a feature is there, that is coded, and then this information is given to the system, computer system, in order to carry out the grid by grid analysis. So grid overlay was one very old method when these digital methods were not available. Then keyboard entry. So alphanumerical and other characters, they are used. You can use the keyboard to enter the data, and nowadays also this lot of attribute data is entered through the keyboard system. The third one is the digitizer here. So if the data is not available in the form of digital maps, then the digitizer is required. We can convert those paper maps into first of all the vector maps. Next is the scanner. In fact, the scanner and digitizer, they are sometimes used together. So first of all we scan the paper maps, and when we are scanning the paper map it become a raster data, and from that raster data we are displaying it on the computer screen and we are carrying out the digitizing activity. If we have big paper maps then and a big digitizing table, we can actually put our paper maps on the digitizing table and carry out the digitizing activity, manual digitization, without scanning it. So these digitizer and scanner are the methods where lot of paper based information could be converted into digital. Then other ways could be the field based methods, are there, using total station, using GPS, using laser scanners. We collect the data and use straight away into the GIS platform if it is a georeference data. Then digital photogrammetry and remote sensing are the other space based methods to give the data input. There are some data which is available in the digital form, either from the internet or from directly from the government agencies. You can procure the data in digital format and can use along with the other layers, other data products which you have created out of it. Now, this is a grid lay method where a very old method where a transparent sheet is superimposed over the existing map. So you can see map of the whole world now has been divided into the number of grids. So a transparent sheet, if I keep on the top of it and then like to see which are the grids where the land mass is falling, and if I represent that information in the form of the grid cell as I shown on the right, the grid cells which are occupying the land mass, they are shown by the black color, and the other grids, the remaining grids which are falling within the sea area, they are shown by the white color. So this is a digital now representation, because each and every grid now has either the land or the water. So that is the attribute and its coordinate systems are there. So it has a three attributes now: coordinates, x, y, and the third is the attribute land or water information. But this kind of method is pretty time consuming methods, and you have to manually actually carry out that process in order to identify. But nowadays the better methods are available, so no one is using this grid based kind of a method to carry out the conversion from hard copy data products to digital products. This keyboard entry into the GIS system. Now this is also a time consuming, but it is a quite accurate method of doing for a small area. When the area is small, when the number of point, line and areas are limited, this may be quite effective method because of its accuracy. And whenever we need high quality results, we can use, for example, cadastral mapping or attribute data. We have to create lot of attribute data because that data may not be available to us. Ready-made data may not be available. We have generated this data from our field visits, from our other data sources. So this has to be entered into the database of the GIS. So again, this is done through the keyboard entry. Now the important is the digitization part. So it is basically the conversion of all our existing paper maps, hard copy maps into digital format. So when I say digital format, in the digitization process, we are doing the vectorization. We are converting into the vector format. As you have learned that there are two distinct format, vector format and the raster format in GIS. So we are using a big size of digitizers for that purpose, because our maps are also bigger size. This digitizer is like a digitizing table which is connected to my computing device, and a software is used to carry out the vectorization work. These digitizers are available in different size: A4, A3, A2, A0, and with the different accuracy requirements. So depending upon the accuracy which is required, for example, we can get 0.05 mm accuracy with that. So very high accuracy can be achieved when you are digitizing them. There are many companies in the market: HP, Calcom, Suma Graphics. So there are many companies available are there which can make the digitizing table available to you. So if we learn that how to use this digitizing table, this is a flat kind of a platform, a table. It has the three layers. In the middle layer has the embedded grid of wires, and then there is a top layer and the bottom layer, and there is a copper grid of wires where the electrostatic current is flowing and this magnetic field is created. There is a cursor attached to it, and when you are moving the cursor over that gridded table and you press the cursor at a particular point, the coordinates of that point is registered, because the entire table is divided into the gridded format. So this is the cursor based movement along the feature and then digitizing the feature while pressing the different functionalities of the cursor button. So this is also pretty cumbersome method, pretty time consuming method for creating the digital maps. So you can see here this table. So this table you can change the angle, you can have the horizontal or you can have perfectly vertical or at some convenient angle on which you can work with that. Attached to the table is a um, mouse, which is not the ordinary mouse. It is, you can see in the diagram here, it is a 16 button mouse. So different functions are there for each of the buttons here. So you have to keep your map on the top of the table as tight as possible and then select the features and manually start digitizing work on this table. So you can see the person is digitizing the feature from the maps. So this map has been put on the table, and you can, at your convenient working angle, you can actually change the angle of this particular working top. Either you can use some kind of a stylish pen, or you can use the cursor, move the cursor. So in the cursor, there is a small circular mark here, and you have to move that mark over that particular feature. So this is a complete manual process where manually you are identifying the feature on the paper map and trying to digitize all the features with the help of this device. Now this there is a certain procedure for preparing the map before you start digitization. You have to identify the features which you are going to digitize. So it could be a line feature, it could be area, it could be polygon feature, or all. So you have to identify which are those features, because you may not like to digitize the entire map. Maybe if you are carrying out some analysis of road network, maybe you identify the roads to be digitized, maybe some river network, maybe the habitated area, maybe the forested area. So these are the features which are prime importance to you. So you can be selective while you are digitizing the features. So then when you start your digitizing process, you have to give the some input to the algorithm. You have to define the coordinate systems in which you want to work. It works in both the systems, either in the Cartesian coordinate system or the latitude and longitude systems. You can convert one system into another also. Then if the map has a lot of wrinkles, if the map is old, then you have to actually uh, take a fresh copy, Xerox copy of that, and then use this. Now when you are doing the digitization of the maps, there are two ways by which you can carry out the digitization. One is the point mode, another is the stream mode digitization. So it is clear from the name itself also what we are doing. So we are actually at the point, at any point you click, and that point is basically registered by the software and determine the coordinates of the point. So if you are digitizing a line, if you are digitizing polygons, then you have to enter or digitize various points on that. So wherever you enter the point mode, this will register and will join by those points, make the line feature or make the polygon feature. But in streamline modes, what will happen is that it will continuously take the coordinates of the points wherever you are moving the cursor, and join in the form of the smooth line stream mode. So this is the diagram which shows, the line has been represented by 4 points only, and in the stream mode it has taken the several number of points. So the advantage of the point mode is that you are operator is very selective. So wherever there is a curvature, wherever there is a change in the direction of the line, you just take that particular point. So your starting point, node point, and then you have the vertex point in between, and then you can actually be selective. Wherever there is a curvature, you take more number of points. Wherever there is a straight line, you have to just take 2 points at the end of the straight line. But in a streamline mode, irrespective of the line which is taking the curve and which is taking a turn, it will keep on taking the coordinates of those points. So it will generate a large number of points for the same feature. But these two modes are available in the digitizer. When you are carrying out the digitization work, then there could be some errors because you are manually carrying out the digitization work. This digitization is also known as the heads down digitization, because your head is always down looking at the map, and you are identifying the feature and carrying out the mapping work. So if suppose your hand is shaky, then also you create certain errors while you are digitizing the features. If the lighting conditions are poor on the table, then also you can have some kind of error. So the error could be like overshoots or the undershoots, or you can have spikes while you are digitizing a straight line. Suddenly there is a spike, or due to the shaky hands while you are doing the digitization work. So this is the example of the overshoots. So the lines are actually uh, exceeding the when they are intersecting the another line, they are exceeding while they should have stopped at that location only. Undershoot is that line has not joined the other line, so it is stopping just before that. And this is the spike. It was a straight line, but suddenly there was a jerk in your hand and you got the spike. So this is not the true shape of these are all the errors in the, or maybe you have digitized a line twice by mistake. So then also you are going to get some error in the data sets. So you have to actually remove that digitization error, whatever error could be present, and there are functions available. There is a function called snapping function. So there is a snap tolerance which you can define in the algorithm, and then if there is a small gap within that snap tolerance distance, it will join it together. So there is a dangling arc function which will actually cut down the overshoots and will make a perfect joint here. So this snap tolerance will join together, and dangling arc, the overshoots will be removed. So there are actually functions available by which the small errors in your data sets could be removed. Then there are sliver polygons are there. When you are having the common boundary, or when you are superimposing one over the other, you create lot of sliver polygons which are to be removed before you carry out the analysis. So this is also important. I have shown you earlier also, but this diagram will make more clear that this particular line is actually digitized twice, and you can get intersections of those two lines will create additional polygon, or one particular vector map has been superimposed on the another map. So you have two more polygons which are created over here. So these are to be taken care when you are carrying out the analysis for such maps. Now scanners are also used, because these digitizing tables are the heads down, very laborious, very time consuming process. So at present they are not used. They are very rarely used. We are using nowadays the scanning process and heads up digitization process. Heads up digitization process is the process where you are using the computer screen, and you are digitizing the features looking at the computer screen itself. So first part of that is the scanning process. You are scanning the map, converting the paper maps into the digital form. When you are converting into digital form, the output is in the raster format. So it is in the form of the grid, and then using the this raster format, you have to carry out the vectorization process as you have done with the digitizing table. So scanner is also connected to a computer, and there are certain scanners, which are selective in nature. That means they will select a certain type of feature. So if you want to select, so let us say, the green features in the maps, the forested area, it will only scan those green features. They are available in different resolution from 300 dpi to 1000 dpi, and different size: A4, A3, A2 and A0. So this resolution and the size will determine the cost of these scanners. There are several companies nowadays in the market which will provide you different range of scanners, from small scanners to the big scanners, from black and white scanner to the color scanners. But if we look at the broad categories of the scanners, there are mainly two types of scanners which are available. One is the line scanner and another is the drum scanner. So these line scanner will scan line by line, and drum scanner, there is a rotating drum where the map is pasted and the entire map is scanned. So here we have a very high resolution camera fitted to the arm of the scanner, and it scan the map line by line using the laser scanning system, and the map will move in the forward direction. So one scan line is completed and the map is moving in the forward direction. So this is the X movement, this is the Y movement, and by having these two X and Y movement, the entire map would be scanned after a certain time. So more the number of DPI, higher is the resolution, the slightly you will find the lower would be the speed of the scanning. But these, when you are scanning the maps with a very high resolution, you are creating a lot of pixels there, lot of grid cells there. So the storage capacity will of that particular map will be much higher. So that has to be taken into account. So these are the this is the diagram which shows actually how the line scanner maps look like here. So you have here two shortcomings is that you want better and better resolution, but you end up getting the more and more storage capacity of it. And the second thing is that most of the scanner will scan the whole thing, the entire thing. While you are digitizing the maps, you are very selective that you digitize certain features which are of interest to you. Then the second category is the drum scanner. As is clear from the name, there is a drum here and the drum will rotate. The map is actually pasted on the surface of the drum, which is the curved surface, and the rotation of the drum, let us say this is the x-axis, and there is again a camera system which will scan of the whole of the map, and will scan the map very fast because of the speed of the drum. So here these kind of drum scanners, they are used for heavy work, heavy industrial work. They are not used for the normal simple kind of a GIS work. So we are using mostly the flatbed kind of a scanners for the normal GIS work. So this is how the drum scanners looks like. So whenever there is a heavy production work required, so these kind of scanners are used for industrial applications. These are very expensive, this is the problem. Then editing also, when you have to carry out the editing, it will take as much time as the manual digitization work. So these are the different problems or merits and demerits of each type of those scanners. Then when you are doing the automated scan from these scanners, you have to make sure that the paper should be wrinkle free. That is number one. Number two is there should not be any spot. If there is any spot on the old maps, then that will also be scanned like a feature. So this is like a coffee cup stain on the map, and this will also be digitized like a feature when you are doing that. So now we have scanned the map. We are using a technique which is called on-screen digitization, heads up technique. Heads down technique was the technique where we are using the digitizing table in order to create the vector map. But here, once we have created the raster map and we are displaying it on our computer screen, now we are using the capability of the software to create the vectorization map. So these are the steps from paper map. You have used the scanner, you have created a raster map, and now it is the heads up digitization to create the digitized vector. Again, the human intervention is required. So manually this has to be done. But the advantage here is that the information is in the digital mode, so one can actually have the zooming of the features also in order to see the clarity. If there is a certain feature which is not clear at the same scale, then it can be zoomed and then create a new map. So this heads up digitization process is considered to be less cumbersome process as compared to the heads down digitization process. So one can digitize again the features which are of interest to us from the raster data. So this is the heads up digitization process where you can see the in the comfort of the environment in the lab, one can start digitizing the features on the computer, and the features which are of interest to us are only digitized from the scanned data set. So scanned data set is very heavy data set, but the features which you are extracting and you are creating a vector map is not that heavy. So the base map is using for digitization work, and sometimes if the quality of the base map which is scanned, again you find that it is not very good, then you can use the enhancement processes which you have learned in image processing. You can apply some of the enhancement process and enhance the image so that the features are more clear, whether this is a road or this is a canal or this is a pipeline passing through the area. And view the zoomed view on the screen and then carry out the digitization work. Now remote sensing data is available to us directly in the raster form. Digital remote sensing data is available in as a raster data input. So this also becomes a important input to the GIS activity. So a lot of people are directly using this remote sensing data product and converting from this the vectorization map. So a road map can be generated, like the drainage map could be generated, or I can manually digitize some of the features like a land use map can be created. So this is a very important input to my GIS. So this is example shows that how the satellite image which was in the raster format can be used actually to digitize the buildings, the each and every block of the buildings which is digitized in the green color, and one can see down below. Down below is the digitized results from the raster data which are shown on the top. So down below is the vector map, top one is the raster data, and this vector data now I can club with the other data products in order to carry out the analysis. So finally, I can have this kind of a thematic map generated directly from the satellite image. But this is a very cumbersome process. It is time consuming process as compared to the analysis which we are doing using some algorithm. But this is much more accurate process here, because manually we are identifying each and every feature and digitizing only those features which we require for our analysis. So we can actually get this kind of a land use maps from the data. Now accuracy in digitization is very important. We may have several errors present in the data sets. So these errors could be geodetic error, maybe the improper choice of the projection system. When the area is large, when there are actually lots of undulations in the hilly areas, there the proper projection system is very important. There could be a inherent error in the machine, in the systems which we are using, and there could be error in the manuscript which you have used for carrying out the digitization work. So quality of the map, you may have a lot of wrinkles, but probably the old maps. So we have to take care of the accuracy part also. Then ground and field based survey can straight away be used as input to the GIS, whether the data is available to me from GPR or GPS or total station or laser based devices. I am directly getting the X, Y and Z data. So this is directly I can use it along with the other data sets. Then there are other data as input. This other data could be the data which is collected from the drone, or we have the spatial raster maps or point cloud data, or the real world 3D coordinates. So all that data altogether I can use in the GIS system. There are external databases available. So we have lot of data now which you can procure, and it is available in digital format or maybe download from the internet. So these are the external data sets also which we can use in our GIS along with the other type of data which we have created from digitization and scanning process. So which method of data input to use? It will depend upon our application part. It would also depend how much time we can devote, how much efforts are required to capture the data and then convert the data and create the entire database which is error free. Now, what is the cost of the method if we are using a particular method of data capture? As I told you, the digitization process from digitizing table or maybe the heads up digitization, they are all very laborious kind of work. They require a lot of time. The it will depend upon the accuracy, what kind of accuracy we require, and also what is the existing digital maps available for a particular project. So depending upon the many factors, we decide that which method of data input we should use. Maybe we have to use always more than one method to give input to the GIS. Thank you very much.